Hey everybody, Paul here. We're going to go over one of the types of problems that you're going to be solving in Deltamath. This one, notice, is the compounding solve for future value problem. Um, just a reminder that we've learned through the idea that these scenarios have a future value, a present value, a rate, and a time. And they normally have three of the four of those things. And so what you're doing is you're generally identifying three of the four, using whichever is the appropriate equation to use, and then solving for the unknown thing. And in this case, what it says is that we are solving for the future value. So somewhere hidden within this is going to be the present value, the rate, and the time. That's what we're going to be trying to pull out of this. And then we're going to also figure out which of the four types of models we should use. So let's see. Dylan, we know Dylan. Dylan invested $7,200. So if he invested that much money, that implies that that should be the present value. That's how much he initially invested. Should have a P, right? So I know that my present value is $7,200, right? And he invested that in an account paying an interest rate of 2.3%. So that lets us know that the rate is, now I'm going to convert the rate from a percent to a decimal, and I do that by dividing it by 100. So we know that this is going to be, make sure this weird little calculator thing is on, 2.3 divided by, 2.3 divided by 100. And that gives us that. So that's our value for our rate. Our rate is 0.023. 2.3% compounded. Oh, compounded quarterly. So that lets us know that we are using the periodic compound interest. So we're going to be using this. Let me use a color for that. I'm using this one. And also note that this formula, right, has that n value. So we're going to have to find that in the scenario as well. Notice sometimes we have an n value. But that's great. So now let's finish this up. Assuming no deposits or withdrawals are made, how much money to the nearest dollar, this is important, would be in the account after 12 years? 12 years is our time. So we have a time of 12. And the question is, what's our n? And this says it's compounded quarterly, and that means 4 times a year because there's 4 quarters in a whole. So n would be 4. We don't know our future value. That's what we're solving for. And there we go. So we're going to take these 4 things. We're going to kind of like put them into this formula, and we're going to solve for future value. So let's see. We get, I guess I can write it right here so we can all see it, right? So we'll get future value equals 7,200 times 1 plus 0.023 divided by 4 to the power of 4 times 12. And I'm going to put the 4 times 12 in parentheses, even though you don't have to because it's grouped over there, just to remind us that this whole thing is the exponent. Okay, great. Let's plug this into our calculator, right? So we get 7,200 times 1 plus, that didn't work. This thing is weird now. 1, let me try this one more time. 1 plus, yeah, this calculator doesn't work very well if I can't make it add things. You know, you think, oh, there we go. 1 plus 0.023, close the parentheses, and then to the power of, oh, and notice it put everything up in the power, so I theoretically don't have to use parentheses in that case, right? But I could have, in this case, I could have gone to here, delete, 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 delete. I could have put the parentheses in. And if you're doing this on like a non-calculator like this, that's not a graphing calculator, you probably want to do that because it's going to help you make sure it's that. And then we give it a look, and oh, I clearly forgot something because it's late at night. It's divided by 4, and that is raised to the power of that. There we go. So that should be it. Okay, let's see. And there we go. That's our future value. And this one's lucky because actually, if we were to do it in the way that we normally would do it, we would write this as future value equals $9,481.01 because we can see that it has the 7 and that tells us to round this up to 1. But our problem said to the nearest dollar. And so in fact, we don't need that plus 1, or that 0.1. And we're just going to have that. That should be our value. So I'm going to pop into Deltamath and see. Just make 9,481. 9,481. And we click Submit Answer. And we're good. And the great thing about Deltamath is that it shows you, in case you got it wrong, it kind of shows you how to approach it. Now notice they did things a little bit different. They simplified the exponent right here, which we didn't really do, but you could. Besides that, it's pretty much the same thing. Okay, and there you have it. Hopefully that makes sense. Again, as always, if you have questions about this, please reach out to your teachers. We are here to help you, and we want you to be so successful. Everyone, take care. Bye.